Hey everyone. So we live in a world that's just obsessed with the latest and greatest, right? We're talking carbon fiber, space-age composites, and it's easy to look at good old steel and think of it as, well, a relic of the industrial age. But is it really? Today, we're going to challenge that idea pretty hard and look at why steel might just be more futuristic than you think. Let's dive in.
It's a fair question, and you hear it all the time. You see these high-performance cars made of carbon fiber, the newest airplanes built with advanced composites, and you can't help but wonder, is steel getting left behind? Is its time as the #1 structural material finally over?
Well, before we jump to any conclusions, just look at this. This is the headquarters for ASM International. And that incredible dome, it was built way back in 1959. This isn't just some pretty piece of architecture. It's a powerful statement about steel's enduring strength and its amazing flexibility. This thing suggests the story of steel is far, far from over.
Okay, so let's get right into it. We're going to dig into the reality behind this myth that steel is on its way out. Because the truth is, it isn't just surviving, it's actually thriving.
And look, the evidence is everywhere. Decades of research and just looking at the world around us confirms that for big projects, we're talking buildings, bridges, you name it, steel is still the dominant material. And we're not just talking about any old steel either. The use of advanced high-strength versions is actually on the rise, which points to innovation, not, obsolescence.
So what is the secret, right? What gives steel this incredible staying power? It really all comes down to one super powerful concept. Its secret sauce, if you will, tunability.
Tunability basically means that steel isn't just one thing. Think of it more like a massive family of materials that you can tailor for a very specific job. You need something that's incredibly, unbelievably strong? You can tune the steel for that. You need it to be more flexible, maybe to withstand earthquakes? Yep, you can tune for that too. It's this almost chameleon-like ability that makes it so incredibly powerful.
Okay, so how do they actually do that? How is this incredible adaptability achieved? It all boils down to two key factors, or levers that can be adjusted while the steel is being made. Let's take a closer look at what they are.
It's kind of like making a cake, really. You have two main levers. The first one is the recipe. That's the composition. On the left here, you can see that by adding really tiny, precise amounts of other elements, things like manganese or chromium, we can fundamentally change the steel's basic properties. The second lever is the cooking, or what we call processing. This is all about applying very specific heating and cooling cycles to the steel. This changes its internal structure and gives it the exact characteristics you're looking for.
So, that's the theory. But what does all this control actually mean in the real world? What does it deliver? Let's check out the advantage in action.
Now, this is where steel really starts to show off. In material science, there's almost always a trade-off. If you make something stronger, it usually gets more brittle, meaning it snaps more easily. But with steel, there's a technique called microalloying that lets us increase its strength, its toughness, and its ductility. That's its ability to bend without breaking, all at the same time. Getting all three of those at once is a huge deal, and it's what makes steel so incredibly versatile.
That combination of properties, it sounds impressive, but what does it actually look like in practice? Let's put some real numbers to it so you can see the actual impact of all this tunability.
Okay, take a look at this chart. On the left, you've got a base steel with a hardness of about 205 on what's called the Vickers scale. Now, just by applying a specific heat treatment, that's our cooking process we talked about, we can more than double that hardness to 438. That's a perfect clear-cut example of how just the processing alone can dramatically change a material's properties, even without touching its recipe.
And what does a performance boost like that mean for the bottom line? Well, it's huge, because engineers can tune steel to be so much stronger they can simply use less of it to do the same job. Just upgrading from one standard grade of steel to a stronger one can lead to material savings of over 20%. And that means lighter structures, lower costs, and using fewer resources. That's a win-win-win.
So where does steel fit into the big picture with all these other materials? As you can see from this quick snapshot, it's not about steel being the absolute best in every single category. Of course not. Aluminum is way lighter. Titanium has a fantastic strength-to-weight ratio. But steel's key advantage, its superpower, is its unmatched balance of cost and performance, which, remember, can be tuned for almost any project. And for a huge range of jobs, that makes it the most practical and economical choice, hands down.
Which brings us to the future. Because of this incredible adaptability, steel isn't some static, boring material. It's really a platform for constant innovation and integration.
So, why are we so sure steel's future is bright? It really comes down to three things. First, there's continuous improvement.
Scientists are always coming up with new alloys and new processing tricks that expand what steel can do. Second, economic scalability. That tunable cost-performance balance makes it the right choice for projects big and small. And finally, and this one is so important, is infrastructure compatibility. New steel innovations can be used with the welding, fabrication, and construction methods we already have all over the world. That's a massive advantage for getting new ideas adopted quickly.
So, in the end, maybe we've all been asking the wrong question. It's not about if steel is ever going to be replaced. I think the real and frankly more exciting question is this. As our engineering challenges get bigger and more complex, what incredible new properties are we going to unlock by tuning the king of materials next?